I'm Paula Hollywood, Senior Analyst, and this is Digital Transformation Viewpoints podcast is brought to you by ARC Advisory Group. In each episode, we'll ask the big questions of how the world is adopting to emerging technologies and practices for sustainable manufacturing. Today, our focus is on the concept of design for reliability. I'd like to welcome and thank our participants. We have an all-female cast today. Joining me are Sandra DiMatteo, Global Director of Marketing, Digital Twin Solutions, Asset and Network Performance at Bentley Systems, and Marie Getsug, Program Manager at Jacobs. Thank you, ladies, for joining us, and welcome.
Glad to be here.
Thank you, Paula.
Okay, I asked these ladies to join me today because Sandra is the person that introduced me to this topic many years ago, and Marie is the most passionate person I've encountered on the speaking circuit on the topic. So that's why I brought these women together. So Sandra, could you start with telling us a little bit about what design for reliability is?
Sure, Paula. So how about we start with the goal, reliability. So, we rely on our physical assets, of course, to meet our business goals. So we need to design in reliability and resilience at the outset of the project, of course, and we need to eliminate unreliability and operational problems throughout the operating life, of the asset. All our assets are complex. They're made up of systems, subsystems. They depend on the reliability of each and every component that make up those critical systems. So, reliability in and of itself is the probability that the asset's going to continue to perform over a specific period of time under specific operating conditions, and you think about in industries like oil, where now the price of oil's crashed again, and, we're in the midst of this pandemic. Operations are now forced to think differently when it comes to operational excellence and how to become more efficient and effective to survive. So design for reliability. Marie?
My goodness. Well, I think you said it very well there, Sandra. I guess I'd add that in the very classic sense of the word, it is a methodology that blends statistics, probability, reliability theory, engineering analysis. And my favorite is really the subject matter expertise of folks who have experience with the assets that we're using, so that we can really honor and glean their expertise and integrate it early in a capital project, for example, so that we can reap those benefits of that experience later on.
Yeah, agreed. It's systematic, it's streamlined engineering that actually drives reliability into the asset life cycle. It absolutely is dependent on the people, the expertise, and also the integrity of the data, which we'll talk about later.
Yeah, I think that's becoming increasingly important as we go forward. The old method of doing projects is just too costly, and it can't persist. So what is the engine for driving this movement of design for reliability? Sandra, you want to start us?
Sure. So achieving performance goals, in the past, it just meant throwing more money at it, right? Upgrade, modify, add on. But if failure is not an option, it's about proactive and timely identification and elimination of those defects, before they occur, related to obviously lost performance and reliability. So upgrades and modifications, they need to be designed with closer tolerances to be reliable and resilient to meet customer expectations. So from that, initial value statement of the asset and measuring performance against that baseline throughout the life is essential. The reality is that there's going to be failures. We know from the science of RCM or reliability centered thinking that most failures are random. But this is where asset performance management, or an APM process, comes in as, I would say, an engine to systematically monitor the degradation of equipment condition and understanding its risk profile. So it's sort of akin to like a control room for operations. Now we've got asset health analytics and dashboards for maintenance and reliability. All right.
Wow. So building on that, Sandra, it almost sounds like that's the digital alignment, and taking that to another layer, maybe integrating the individuals that can find those defects and then capture them in the asset performance management system, so that ultimately every step of the way of the journey as that asset matures, we've got a defect discovery and prevention process in place. And those defects don't necessarily have to be blatant defects. It could be a fine tuning of what is going to really help this project deliver the functionality that it is intended to provide.
So, building on that, what would you say is the value proposition of DFR? That's Design for Reliability. I'm going to use that acronym now. We've established it, Marie?
Well, I think that Design for Reliability promotes value proposition based on really the whole asset life cycle. And one of the, I guess you would almost call it a paradigm shift. It's kind of an old term from the 70s, but is instead of us just focusing on cost, scope, and schedule for capital projects, finding ways to focus on the total cost of ownership, looking for those differentiators that are going to improve that ultimately the total cost of ownership for that asset and for that project throughout its entire life. Not just looking at reliability, but also performance. What's the startup going to look like? What is the transition between that CapEx and OpEx phase? And how are we integrating that knowledge from the stakeholders that have experience throughout the entire life cycle? So by honoring those subject matter experts, I believe that it also becomes a value proposition in terms of it becoming a inspired design for reliability culture that we can establish by making sure that it is all inclusive and integrated.
Yeah, I do see movement in that direction from many corners. So again, we talked briefly about the expensive projects and trying to bring that down and get it under control, as well as a lot of automation suppliers are talking about that. So I definitely see a movement in this direction. How does Design for Reliability help to manage risk, which is really the whole point of APM, as Sandra mentioned earlier? Sandra, can you expound on that?
Sure. So I really think the whole point of DFR and APM is, I'd say, to minimize risk to the business. So we use things like risk prioritization as a key assessment, to guide reliability projects. That's essentially the probability of an asset failing multiplied by the consequence score of failure. That's how we get the risk prioritization. So the criteria that we use then in scoring are based on the business goals throughout the life of the asset, of safety, environmental integrity, cost, reputation, service level, output. So, we need predictable production, and we're looking for, measurable and I'd say immediate results. But of course, this is dependent on the level of control that we have on the reliability process throughout the life cycle. I know you mentioned culture and process, that whole people process technology. Back to that engine of APM, I think of that define, measure, analyze, improve, control, to make that data-driven improvement cycle used to optimize and sustain business processes and designs. Marie?
Well, so building on that, which is kind of hard to do, Sandra, I find that sometimes it's a strategic blunder that will drive a company to decide that Design for Reliability is really what they need. And that strategic blunder is typically a risk that hasn't been proactively foreseen. For example, not being first to market, or, hey, let's try out this new technology, and there's surprises along the way that really were not managed as a conscious risk that they realized they were getting into. So I kind of like to relate it to today with COVID pandemic. I've been working on and just sitting here contemplating, what are we going to do and what are we trying to mitigate that's different? And I would suggest it's exposure. It's exposure to the virus and trying to understand how that virus can flow. And if we're looking in a building and you start contemplating the HVAC system, the heating, ventilation, and air conditioning systems, and the building management system that controls it, and unlike a pump, you can't say I want 100% filtration of all the air through this. You can do a number of exchanges, but you can't say I'm going to capture this molecule that's up in the corner of the ceiling, right? So identifying these risks and really having a strong management system that allows us to identify that things that we don't know, which I guess is kind of a statement that I've been saying for years is, that's really what design for reliability is all about. The discovery of you don't know what you don't know and honoring the expertise of those who may have some expertise in those different areas.
Well put. That's an old ARC mantra, if you will. You can't control what you can't measure, kind of along the same things. And if you don't plan for it, obviously you're going to get into trouble. And your COVID analogy is quite appropriate in that instance. If we could move along, how important is stakeholder analysis to DSR? And when should stakeholders and SME get involved?
Well, firstly, I would say nothing happens without executive support. We need to have a vision. I've seen it happen when with the commitment at the C level, to have that vision of a comprehensive asset management program before an asset is even commissioned, they're structuring for success. I've seen that happen to get a comprehensive program in place even before startup. And I guess secondly is, in terms of the stakeholders, how do we design to ensure we have collaboration between engineering, operations, and maintenance? Between those disciplines, they need to interact differently with the data perhaps, but they have to have access to trusted information.
Okay. Marie?
Yep. I got to say that this executive sponsorship is just becomes more and more clear that is so important. I mean, I think a lot of us have historically done things completely out of passion, and there's only so much lack of support that you can overcome with passion. So I would certainly build on that, and then really think about stakeholders that you may not typically include early in the project, and finding ways to establish partnership programs that will incorporate their expertise. And one of my favorites are the OEMs, so the original equipment manufacturers that build equipment, and identifying those who are really looking to be on the cutting edge of their own designs, how they can bring total cost of ownership and improve designs to the table, and even offer those as options rather than just responding to an RFP that can be so generic that you don't always get the expertise of the folks that you're asking for a proposal from to come out in those. So, certainly facilitating and getting maintenance, reliability, operations, engineering, quality, safety, resilience. It's going to be the COVID department now too. Getting everyone's input and making sure that there's a balance among how they're integrated. And at the same time, I don't think we see that much of a difference. They seem to really be complementary a lot of times, as long as the core principles and values for each of those stakeholder interests are solidified and agreed upon up front. And that would be back to the executive sponsors that are establishing those.
Yeah, agreed. I'll share this short anecdote with you. I ran into a gentleman at one time at a Bentley conference, actually, and he was talking about a building design. And the location of the building was located in the Northeast, which is a snowy part of the country. And the roof was apparently not designed with maintenance in mind, and the ability to shovel the snow off in the winter should that happen. So by involving the maintenance team in that process, that flaw was uncovered right from the get-go, that nobody would go up there and do that. So you're going to have to change the design. So that's just a quick example of the kind of thing that we're talking about. What's the difference between design for reliability and reliability-centered design? Marie, would you like to kick that off?
Sure. This has been a subject I've debated with my very dear colleague, Ramesh Gulati, and with even Terrence O'Hanlon many times in the last few years. Based on how I'm seeing the two of them applied in industry, I would suggest that reliability-centered design is much more of a point solution, and it is typically grounded in a failure modes and effects analysis to help us understand the criticality. And specifically, a lot of times it is accomplished at the 30% design for a capital project. I believe that design for reliability is much more of a fully integrated solution that deploys all kinds of methodologies, not just FMECA and not just RCM, but that stakeholder involvement and partnerships like cycle costing, constantly looking at and bringing in different perspectives to see how the maturity of the asset is coming along and how it's going to impact its performance. So I guess that would be the difference in my mind is one's really a point solution. And I would say design for reliability is really more, is very similar to asset management in the same way that maybe reliability centered design is to, I was going to say maintenance and reliability, but I'm not sure that's really accurate. I think it's much more just a point solution and a tactical approach at a given point in a project.
Okay. Yeah, I think you're spot on, Marie, in the reliability-centered design. It's not really a design process, but it's just evaluating, say, in the design phase from the perspective of reliability. So a proactive approach, say, to risk management, perhaps, during the design phase. And it's leveraging the principles of reliability-centered maintenance, as you mentioned. Whereas DFR, designed for reliability, is, as you say, throughout the whole asset lifecycle, it's systematic, streamlined engineering that drives reliability and focuses on continuous improvement.
Yeah, this reminds me of the whole concept of, well, my focus is reliability and I'm being proactive, so I must be doing reliability-centered maintenance, RCM. Well, no, that's not really the case. RCM is a prescriptive process, and unless you're following it, then you're not really doing RCM. So perhaps it just comes down to semantics. I'm not really sure. Maybe I think it does in that case a lot of times. A lot of marketing spin, too, I think, plays into that. So may I ask you, how do you see IIoT technologies impacting DFR? Sandra, can you kick us off?
Well, I mean, I think people are just beginning to realize the importance of having a whole digitalization framework around this. I mean, if you had the opportunity to design a new plant from scratch, you'd surely maximize your IIoT technologies, everything automated sensing devices, less human intervention, to monitor the asset's conditions, the less prone to error, theoretically, right? Edge devices, with AI built in, great to have intelligence built into the device at the edge. But there's also that false sense of security. I think we still need that overall system level, monitoring to bring all the data together to be able to collaborate, analyze, provide visibility at that system level to make better decisions. So as digitalization and IIoT adoption increases in an enterprise, data is going to grow exponentially. At the same time, the underlying engineering information is changing over time as well with every added sensor, every design modification. So as a result, accessing the right data at the right time is often, so time consuming and troublesome. And that's where we get into problems with reliability when we're not sure of the accuracy of our data. And, I think of this as sort of line of sight. It's important to ensure line of sight, or maybe digital line of sight, meaning that management has proof in digital format of accurate information, to make decisions, and that workers have the proof that they need, in digital format, again, of the reasons behind, doing their daily activities.
Well put. I was going to say, this has been a subject of personal curiosity and challenge for me in the last few years, because I always felt like it was this cloud thing that was way beyond what I would understand or how I could use it. And I got to tell you, there's been a couple of things I've been involved with that have really made it much more tangible. And I like to share the story because hopefully a lot of folks will resonate with it. I find that like the entire platform that Bentley provides is there to really optimize and utilize the information that we have and find ways to complement like one perspective versus another. Yet it has to be grounded in the actual tactical application out in the field. So when we were putting in a design for reliability program for a global client, they decided they wanted to do a RAMS analysis. And actually this has been part of the toolkit for design for reliability. So what a RAMS analysis does is similar to the reliability center design at 30% design. We can go in and say, hey, is this design that we've put together even capable of achieving the availability that is required for this project? So it's it really does ground itself in a lot of the statistics. What I find fascinating is that by doing the modeling for a RAMS analysis, that can then feed a simulator that would give us the ability to, let's say we're going to have a product change. In biotech, you may have a cancer drug, and then there may be another variation of that cancer drug that instead of going after these organs, it's now going to be able to go after those organs. And being able to simulate that with these IoT solutions that allow us to challenge a design and see what are the opportunities to change that design and what things do we need to do with the physical world to be able to realize what we're looking for. And the other example that comes into play is a lot of times these simulations are simulating the difference between a frequency-driven maintenance program that requires a lot of intrusive maintenance activity and a more of an RCM, reliability-centered maintenance-based program that's going to really leverage on condition and reduce the amount of intrusive maintenance that we're accomplishing. So the intersection between that, I would say it's really kind of the intersection between the strategic digitalization framework of IoT and the tactical application of the folks that are going to be operating, running, maintaining the plant in the OpEx phase is where it really comes to life, because it'll both visually show us the evolution and maturity and then ultimately allow us to challenge that design to be able to make modifications and do different things than it was maybe originally intended to do. I don't know, Sandra, what do you think?
I completely agree, Marie. Good examples.
Yeah, very good. So I know that you actually, the two of you have not worked together before, but your companies have at least shared projects. Can you share an example of how Bentley software would support Jacob's project, and how does the end customer benefit? Sandra?
Sure, I can start. One example, and we have many, of course, is Network Rail in the UK, and they've been using our software for many years, not only on the operational side, but also there's been a recent project on their on a route upgrade project, and when you're looking at designing and on an upgrade project like this, in talking to the project managers there, what really came through to me at the value of the Bentley software has been the accessibility of that information to all of the stakeholders. So they have an open, connected data environment, really probably for the first time, I don't know, I hear this all the time, is being able to see all of your various sources of data, 1D, 2D, 3D, all in one place. As I said before, different, same here, that different people will have different disciplines, will have different uses of information, but the fact that they can access it in one location is really powerful, and something you need today to aggregate all that data from multiple sources in an evergreen, open, connected data environment.
Marie?
That's fascinating, because it was truly Network Rail and my colleagues in London who demonstrated how these different layers have been used for our client, our common client here of Network Rail. So one of the layers is property managers. You're like, well, how in the heck would you use property managers? Well, if you're going to go figure out where you're going to put a site, or if we're running a rail, what property is it going over? Which property owners are we going to have to collaborate with or negotiate with to be able to accomplish that project? And it could be for a manufacturing plant. It could be for transit. It could be for an airport. And then it may be more about the sound and where the paths of the airplanes are going. So understanding, things like the property owners one was just really a unique one to me. And that was used to really figure out how to put a manufacturing plant close to a neighborhood and bring it up very quickly for a biotech solution. The other kind of examples and layers that we work on that I see completely come out of the Bentley software are the GIS markings and being able to understand and overlap weather patterns, and hey, where is this rail going to flood? And therefore it's more susceptible to, needing to be maintained, or making sure that we have drainage properly designed, or what are the historic maintenance activities along the rail, so we can see where there might be. I don't know about you, but I remember back in the 80s, I had to help get an engine back on the track at Frito-Lay because the track was so sharp. When it would bring the corn in, it was common that a few times every year it would jump the track. So, understanding where are those susceptibilities and seeing the layers of even cause and effect sometimes between these layers is fascinating. And it does provide incredible amount of information. It also gives us the opportunity not to have, the red-lined drawings sitting on the table that never gets attention, and really being able to have one single source of truth of drawings and information that we can all rely on.
Yeah, and that really becomes a safety issue too, right? I mean, how often have you heard it takes 6 months for, the documents to be updated, and that just is unacceptable in some cases, right?
Oh, absolutely.
Yep.
And that geospatial reference, I almost forget about it, but even the very simple point of knowing what and where your assets are is not a given. So the fact of having that geospatial reference is really something I take for granted, but it's really important.
Yeah, I think, Sandra, we were looking at a project earlier this morning. I think it was one for Network, and it was like, well, we can easily know how many bridges there are, and I can tell you. As of last week, I have a colleague trying to count elevators in a hospital, and they don't even know how many they have. So it's interesting that very simple factor is certainly important for where we start with asset management and with design for liability.
Very good. Ladies, you're knocking it out of the park, but that's all we have time for today, but I know that you could talk about it all day. So I'd like to thank my guests again, Sandra DiMatteo from Bentley Systems and Marie Getsug from Cabot. For more information on and insights on this topic and to learn best practices to accelerate transformation, please visit the ARC Advisory Group website at www.arcweb.com. Please do subscribe to this podcast so you don't miss an episode. And while you're there, leave us a review. In the meantime, from Paula Hollywood, thank you for listening and goodbye.